GCC, we're back. This is our continuation of chapter 5. We were working some problems. Again, this is a very mathematical chapter with lots of calculations. We've worked the first two problems, and then I asked you to work on the last two while we took a little break. So let's see how you did. If you haven't worked these out yet, hit pause now and work out these last two problems up above. You want to work out the last two and then come back. Okay, here we go. How many grams is 0.0554 moles of water? So we are given moles of water. So let's start with that, 0.0554 moles. We're going to use molar mass to go to grams. We always use molar mass to go back and forth between grams and moles. Now, because we're starting with moles, in our conversion factor, do we want moles on the top or the bottom? I hope you said on the bottom. So that means the grams are going to be on top. So we need how much a mole of water weighs. What is water? Yeah, you know, H2O, that's easy. So we need to add up the mass of H2O, right? So that's two H's, so 1.01 plus 1.01 plus an oxygen, 16.00. Again, those zeros are significant. Don't forget the zeros. Add that together, and we get 2.02 plus 16.00 equals 18.02. And that will be grams over 1 mole of water. Looks like this. All right, moles cancel out top to bottom. We're left with grams. The question is how many grams? So we did it correctly. Let's punch this into our calculator. 0.0554 times 18.02 divided by 1 equals 0.998308 grams. But that's too many sig figs. So look at what we're given. 3 sig figs. Zeros in front do not count. And the molar mass of 18.02 grams is 4 sig figs. We go with the least sig figs. So 0.998 grams of water is our final answer. All right, last one. How many grams is 4.75 times 10 to the 16th atoms of K? What is K? Potassium. Good job. And we're starting with atoms. So this is different than the three above. We're starting with atoms, not moles or grams. Oh, we're going to have to use Avogadro's number first. Then we can use our molar mass to get to grams. This is going to be a two-step problem. Start with what you're given. 4.75 times 10 to the 16th atoms K. Avogadro's number is 6.02 times 10 to the 23rd atoms per 1 mole. Now, because we're starting with atoms of K, for Avogadro's number, which is a conversion factor in parentheses, do we want atoms on top or bottom? We need them to cancel out, so we need them on the bottom. So Avogadro's number is going to be on the bottom with 1 mole on top. Atoms will cancel out. That will get us to moles. How do we go between moles and grams? Molar mass. Molar mass is used to get us from moles to grams or grams to moles. What is the molar mass of K? Well, let's find K in the table. There it is. It is 39.10 grams per mole. Do we need that mole on top or bottom? Need it on the bottom. So 39.10 grams is on top. Looks like this. Let's punch it into our calculator. Make sure you can get this answer. 4.75 EE 16 times 1 divided by 6.02 EE 23 times 39.10 divided by 1 equals. It's a really small number. I put it into scientific notation and I get 3.085132289 times 10 to the minus 6. Sig figs, we started with 3. There's 3 in Avogadro's number. There's 4 in the molar mass. We go with the least, which is 3. 3.09 times 10 to the minus 6 grams of potassium. Make sure you have a unit. It's grams. All right, so we put 2 steps together in that calculation. Hopefully you did okay with these 4 practice problems. These are very important, very basic chemistry calculations. You've got to be able to go from grams to moles using molar mass. You've got to be able to go from moles to atoms or molecules using Avogadro's number, which is summarized in this chart here. Yay, the little chart. If we have grams, we can use molar mass to get to moles. If we have moles, we can use Avogadro's number to get to atoms or molecules. Or the other way, if we have atoms or molecules, we can use Avogadro's number to get to moles. If we have moles, we can use molar mass to get to grams. Okay, and the units let you know whether something is on top or bottom because we always cancel out from top to bottom. All right, I have 2 practice problems for you to try. I want you to hit pause and work on these. Hit pause and work on these. You've got to be able to do these on your own. Just watching me solve them isn't studying. You need to try these on your own. Hit pause. I hope you hit pause. Number 1, how many molecules are in 3.425 grams of carbon dioxide? We're starting with grams. We're going to molecules. That will be a 2-step problem. It looks like this. 3.425 grams of CO2, carbon dioxide. Yes, we're allowed to use chemical names now. You need to know the names of your chemicals. So we have grams, so we need a molar mass of CO2 first. So we go to our periodic table and we need to add up 1 C and 2 O's. When you add up 1 carbon and 2 oxygens, you get 44.01 grams in that 1 mole. Grams is on bottom, so it'll cancel out. Then we have our moles. Now we need to go to molecules, so we need to use Avogadro's number. 6.02 times 10 to the 23rd molecules over 1 mole. Moles cancel out. We're left with molecules. Again, you need to punch this into your calculator correctly. Do not hit times 10. Don't do it. Use your exponent button correctly, and you will get the answer of 4.68 times 10 to the 22nd molecules of CO2. Hopefully you did that one. Let's try the other one. If you haven't tried it yet, hit pause, come back. All right, how many grams will 3.0 times 10 to the 15th molecules of carbon dioxide mass? So we have molecules, but we want grams. Again, this is going to be a 2-step problem. We're going to go from molecules to moles using Avogadro's number. Then we'll go from moles to grams using the molar mass of CO2, which we've already added up. And it looks like this. 3.0 times 10 to the 15 molecules times 1 mole over 6.02 times 10 to the 23rd molecules times 44.01 grams over 1 mole equals 2.2 times 10 to the minus 7th grams CO2. Molecules canceled out top to bottom, then moles canceled out top to bottom, giving us grams. The question was how many grams? So that's good. We got our grams. And again, you have to punch this into your calculator correctly. If you're having any problems with the scientific numbers, please ask your instructor or go to tutoring with your calculator. You need to have a scientific calculator that you can use. All right. Well, thanks so much, GCC.